Today we're going to examine the cosine ratio. Let's start by writing the ratio. Cosine theta equals adjacent over hypotenuse. Now we know that angle theta is this angle right here, which is represented by letter A. So let's write this in terms of A. I have cosine of angle A, which is our reference angle, equals the side adjacent to angle A, which is AB, over the hypotenuse, which we know the hypotenuse is directly across from the 90-degree angle, like it says here, which means this would be line AC. We will look more at cosine in the next example. Let's examine this first example together. Let's start by writing down what information we know first. We know our reference angle is equal to 60 degrees. We also know that the adjacent side to the angle is equal to x. And last, we see that the hypotenuse directly across from our 90-degree angle, which we could see is right here, is equal to 13 centimeters. For our second step, we're going to set up our ratio. We start with cosine of our reference angle, which we know is 60 degrees, equals adjacent, which is x, over our hypotenuse, 13. Now, we have an unknown variable, which is x, which is the side length adjacent to our triangle. We're going to use inverse operations to solve for x. So here we know x is being divided by 13, so the inverse operation is multiplying. And what we do to one side, we do to the other side. These two 13s cancel out, and we're left with 13 times cosine 60 equals x. Please watch the video to ensure you know how to put this into the calculator correctly. For this example, we had x equals 13 times cosine of 60. So we'll type in 13 cosine 60. Hit enter. I get 6.5. No rounding for us to do, just x equals 6.5. Let's try another example together. In this example, we need to start with writing down what we know. Let's start with our reference angle. So our reference angle, as we see right here, is equal to 53 degrees. Next, because we're looking at the sine ratio, I want to know what is adjacent to that angle. So I see adjacent is side equal to 45. Lastly, I need to know the hypotenuse. And here my hypotenuse is k, which is our variable. Step 2, we'll set up our trig ratio. We have cosine of our reference angle, which is 53 degrees, equals adjacent, which is 45, over hypotenuse, which is k. Now we're solving for our unknown variable, which we know is k. So we're going to start by doing the inverse operation. We need to get k by itself, so we're going to start by getting rid of it out of the denominator. What we do to one side, we do to the other. So now we have k cosine of 53 equals 45. We're trying to get k by itself, so now we're going to divide both sides by cosine of 53. And we're left with k equals 45 divided by cosine of 53. Now, what I want you to notice here, once again, we started with cosine of 53 equals 45 over k. We ended with k equals 45 over cosine of 53. If you notice, what happened here is they switched places. So, cosine of 53 and k and cosine of 53. Now watch the video to see how to input this into the calculator correctly. For this example, we had k equals 45 divided by cosine of 53. We typed that in as 45 divided by cosine 53. Enter. 74.77. So we round that up to 74.8. Here's some problems to try on your own. Make sure you use these simple steps to solve each trig ratio. Number 1, write down what you know. Number 2, set up your trig ratio. Number 3, solve for variable. And round to the nearest tenth. Now that you've tried some examples on your own, let's look at some real-world application. As you can see in the picture, we're looking at a plane taking off. We're looking at how many feet he's traveled from the ground into the place that he's at. Now, as we know, planes can't take off just straight up in the air. They have to take off at a certain angle. And we can determine what that angle is looking at how much they have flown from one point to the next, and also the angle that the plane is from the ground. So let's go ahead and write down what we know. We know our reference angle is equal to 60 degrees. We know our hypotenuse, which is directly across from our 90-degree angle, is equal to 1,000. And what we're trying to find is the height of the airplane in the air at that specific point. And that side is the adjacent side to our reference angle. Step 2, we're going to set up our trig ratio. We have cosine of angle 60 equals adjacent over hypotenuse. Once again, we now have our ratio. We're going to do step 3, solve for the variable. So here we'll do our inverse operation and multiply both sides by 1,000 to get rid of the denominator. These two cancel out. I'm left with 1,000 times cosine of 60 equals the height of the airplane. I'll give you a couple seconds to try this problem. Input it into your calculator and round to the nearest tenth. Once you put it into the calculator, you can see that the current height of the plane is equal to 500. Now we will examine inverse cosine. Inverse cosine uses the adjacent leg and the hypotenuse to determine a missing angle. Let's look at this first example together. First, we're going to write down what we know. We know our reference angle is equal to x, which is the angle we're currently looking for. We know the side adjacent to that angle is equal to 14.3. And lastly, we know the hypotenuse, which is directly across from the 90-degree angle, is equal to 19. So our next step is to set up our trig ratio. We have cosine of x equals adjacent over hypotenuse. Now once again, our second step would be to solve for our variable. In order to do that, we do the inverse operation. So the inverse of cosine is written as x equals inverse of cosine times 14.3 divided by 19. Please watch the video to see how to input this into the calculator correctly. For this example, we got x equals the inverse of cosine times 14.3 divided by 19. We type that as second cosine to get the inverse. 14.3 divided by 19, which equals 41.18, which we can round up to 41.2. Now try it yourself. You need to find angle A in this problem. Remember these 3 simple steps that will help you solve any trig ratio. 1. Write down what you know. 2. Set up your trig ratio. And lastly, you're going to solve for the variable. And round to the nearest tenth.